Good morning, student. Today we will start our new topic, that is functional dependencies in DBMS. So we start with the definition of the functional dependency. A functional dependency, denoted as x arrow y, exists between two sets of attributes x and y in a relation if for every unique value of x, the value of y is uniquely determined. In other words, x functionally determines y. Actually, when functional dependency means the relationship between two attributes. Suppose x is an attribute and y is the another attribute. So what is the dependency between these two? Actually, x arrow y means x uniquely determines y from the table and y is dependent on the x. Okay, so there is two key concepts. One is the determinant and another is the dependent. So x is called the determinant and y is called the dependent. Next, relationship between two attributes. It is the main thing of the functional dependency, and in a relation A arrow B means the attribute A uniquely determines the attribute B. Now let's start with the example. So simple functional dependencies. This is an example of this, that is the name, age and major is dependent on the attribute student ID. So student ID here is unique 101, 102 and 103. So these attributes can uniquely identify the row in this table. That uniquely identify the name, age and major. So the name, major and age is functionally dependent on the student ID. Student ID functionally determines the other attributes here. Next, the composite functional dependency. Here, the student ID and course ID are two attributes. One attribute cannot uniquely identify the other attributes. Here 101, 102 and again 101, it cannot uniquely identify the other attributes because here it is the MA 101 Jones and Spring and 101 again CS 101. So it cannot determine uniquely this column. Therefore, we cannot identify student ID as a unique ID of this table. So we are considering student ID and the course ID both as a composite key to uniquely identify the row from this table. So it is called a composite key or composite primary key, and these dependencies are called composite functional dependency. So there is some properties, Armstrong properties of the functional dependency. For these three properties are the main properties of this Armstrong axiom. So it is the reflexivity rule, next is the augmentation rule and another is the transitivity rule. So first one, if the y is the subset of the x, then x arrow y holds by the transitivity rule. So here let us consider the example. The name is dependent on roll number and name is the subset of this roll number and name. So it is a reflexivity rule. Next is the augmentation. Augmentation, if the functional dependency x arrow y is valid, then we can augment it like that. That is the z is added in the both side, in the left hand side and the right hand side, and this is also be true and this is also be valid. This is called the augmentation rule. So we are considering an example, roll number and name and department building. So this is functionally dependent on these two attributes, is a valid Hence we can add this department name and department name in the both side as a augmentation rule, and this functional dependency is also valid. Transitivity rule. The next rule is the transitivity. Here x arrow y and y arrow z, if both exist or both is valid dependencies, then we can say x arrow z is also a valid by the transitivity rule. So let's us consider an example: roll number and department name, and the department name and department building. So we can say that roll number and department building, that means department building depends on the roll number. So x arrow y and y arrow z, if both valid, then we can say x arrow z is a functional dependency. Next is the different types of functional dependencies. So trivial functional dependencies, non-trivial functional dependencies, completely non-trivial functional dependencies, partial functional dependencies, transitivity functional dependencies, transitive multi-valued dependencies. So next I will discuss one by one. The first one is trivial functional dependencies. Here a function dependency is trivial if the right hand side is a subset of the left hand side. In this example, you have noticed that AB, and here it is the A, so it is the subset of AB. So A is a subset of AB, so this is a trivial functional dependency. So this type of functional dependency is called trivial functional dependencies because A is the subset of AB. Next is the non-trivial functional dependency. Here the right hand side is not a subset of the left hand side. So here we are considering an example AB arrow BC. So BC is not a subset of the AB. That's why it is called non-trivial functional dependency. Next, completely non-trivial functional dependency. Non-trivial functional dependency and completely non-trivial functional dependency, there is only one difference is there. There is no attribute in common in the left hand side and the right hand side. In my previous slide, here the attribute B is common, but BC is not the subset of the AB. That's why it is called the non-trivial functional dependency. But here there is no common attribute in the left hand side and the right hand side. Therefore, it is called completely non-trivial functional dependency. Next is the partial functional dependency. A partial dependency occurs when a non-key attribute is functionally dependent on part of a composite key. What is the composite key? You know the composite key means if a single attribute cannot identify the row uniquely in a table, then you are using more than one attribute you can use as a primary key to identify the row, unique row from the table. So that is the composite key. So in a composite key, if any non-key attribute depends partially on the composite key, then it is called the partially functional dependencies. So here you can check student ID, course ID and professor name. There is three things are there, where student ID and course ID is the composite primary key. That means these two attributes can able to uniquely identify the each row of from this table. If professor name depends only on the course ID, not depends on the both course ID and student ID, only depends on the course ID. That means it is this functional dependency is valid. This functional dependency actually is valid. That is the course ID arrow professor name. So professor name is dependent only on the course ID, not on the student ID. That means it is partially dependent on the composite key. So this is called the partial dependencies. Next, transitive functional dependency. A transitive functional dependency occurs when there is an indirect functional dependency if A arrow B and B arrow C is present, then A arrow C is a transitive dependency. So that is already discussed in previous slide. So student ID, roll number, and then roll number, student name, then according to the student ID and student name is the transitive dependency. Next is the multi-valued dependency. Here a multi-valued dependency occurs when one attribute is in a relation means in a table, uniquely determines another set of attributes, not in a single attribute, set of attributes which are independent of all others attribute. In a relation with student ID and course and hobbies, three are there in a relation, and student ID and course ID and student ID and hobbies, these two are the multi-valued dependency, because if there is a student ID is 1, again student ID is 1 and one student have multiple courses. Suppose you can draw this table like that. That is the student ID and it is the course. So course, suppose you are considering the student ID is 1, 1 and 1. Course ID, suppose it is PCC, IT 101, PCC, IT 102, PCC, IT 103. So there is these dependencies are called the multi-valued dependencies, because student ID is same but it contains three different courses. So the courses are the dependency is a multi-valued dependencies. Similarly, hobbies may be different in a single student. That's why there is so many hobbies for a particular student. So this is the multiple value is there. That's why it is the multi-valued dependencies. Next, here we are considering one table, and here is the trivial functional dependency, student ID and course ID and then student ID. It is the subset of the student ID. So it is called the trivial functional dependency. Non-trivial, here there is no subset. Professor is not subset of the course ID. Therefore, it is a non-trivial functional dependency, and here is a transitivity dependency. Example of this: course department is dependent on the course ID, then building is dependent on the department. So here the building is dependent on the course ID. That is the transitivity dependency example. Next, we are considering few examples to clearly understood the functional dependencies. Here we are considering a relation. So it is a relation, or you can say it is a table R, and A, B, C, D are the attributes of this table. So A is the A, B, C, D. You can say it is the attributes of column, name of the column. So this is the functional dependencies are there: A arrow B, B arrow C, and C arrow D. So A arrow D a valid functional dependency. So that is the question. Okay. So yes, because A arrow B, B arrow C, and C arrow D, then you can say A arrow D using the transitivity rule. Using the transitivity rule, you can validate this A arrow D, because if A arrow B, then B arrow C, then C arrow D, then you can say A arrow D is a transitive rule of the functional dependency. So it is valid. Okay. Next, the problem number 2. Here at first you want to discuss about what is the closure of the attributes. Okay. So the set of all those attributes which can be functionally determined from an attribute set. So now we are considering a relation. So these are the column names of this table, R is a table, and then set of the functional functional dependencies are there. Now find the closure of A. So closure means all the attributes which can be functionally determined from a single attribute or a set of attributes. Maybe it is a single attribute or it may be a multiple attribute. So if you want to find out the closure of AB, then you can write AB plus, or if you want to find out the closure of A, then you can write this symbol A plus. So how to find the closure of A? So this is the solution to find the closure of A. So using A arrow B, we can add B to the A. That therefore A plus is the A and B. This is the set contains A and B because A determines B. Okay, so if A determines B, then the set contains A and B. Again, using B arrow C, therefore C also be included inside the closure of A. Again, using A arrow D, the D also be included in the closure of this. So A plus is the A, B and C, D. So all the attributes are present the closure of A plus. So no more functional dependencies can be applied. Therefore, the closure of A is A, B, C, D. So if it contains all the attributes, that means A may be the one of the key of this relation. Next, determine the keys. How to determine the key using the closure? So these are the relations and these are the functional dependencies are there. So determine the candidate key of the relation. So now we are finding the candidate key. Candidate key means the minimum super key. So there is a one type of key is there. So now you are finding the closure of the A. So A arrow B, A arrow C, A arrow C arrow D and D arrow E. So therefore A plus is the closure of the all the attributes. So you can say A can determines all the attributes. A is candidate key. So no other single attribute or the combination of this attribute is required to determine all the attributes, since A alone can be do so. Therefore, the only candidate key for this relation is A, because A from the A you can determine all other attributes, or you can say all other attributes is functionally dependent on A. So therefore, A may be the candidate key of this table. Next, that is the problem 4. Now compute the closure of AB and DC for given relation and functional dependency. So this is the relation and this is the functional dependencies. Now you are finding the AB plus and DC plus. So that is the closure of AB and DC. Now solution is, so you can check the functional dependencies are there and then you can find the closure of AB plus, the closure of AB and closure of DC. So AB, from AB you can try to derive the other attributes from the functional dependency of this AB arrow C, that means AB determines C. So you can add the C into the set of the closure. Then again A derives D. Therefore D you may include in the set of the closure. Again D derives E. Therefore E also be included in the set. So that is the closure of AB plus. And similarly, closure of DC is this one, the reflexivity rule, that is the DC, and again according to this functional dependency you add the E into this set and then this is the closure. There is no other functional dependency by which we can derive the other attributes. Therefore, this is the closure of this DC. Okay. So this is the closure of this and this is the closure of DC. Now next, the last problem, that is the problem 5. here in this schema attributes A, B, C, D and E following set of functional dependencies are this one. Which of the following functional dependency is not implied by the above set? So this one A, B, C and D. So how to find out this? So this is the solution. So at first we are check the closure of CD. So from the functional dependency this also holds the true, which means if CD arrow AC, then you can find this closure of CD equals to this one. So again BD plus BD, which means BD arrow CD cannot hold, it is true. So this FD is not implied the FD set. So the option B is the required option. So we do not require to again check the closure of this other two, because we have find out this, because BD equals to BD, which means BD arrow C cannot hold true. Okay, so this FD is not implied in FD set. So B is the required option.